Hello friends. Today I will discuss why cloud and DevOps is required in IT industry. So first let me introduce myself. My name is Soumik Mondal and I belongs to Kolkata. I graduated from Heritage Institute of Technology in 2022 and after that I am working with a company. But right now I'm more interested to continue my journey, my career in cloud and DevOps. I invested my time, effort, and intelligence to some mega projects like multi-cloud deployments, where you can deploy multi-cloud. What that means? Multi-cloud means multiple cloud means AWS, Azure, or GCP. So I combined AWS and Azure to deploy some application, and I have also done a three-tier architecture deployment with DevOps best practices to ensure scalability, reliability, and performance. So this is my brief introduction. Let's now jump into the today's topic. Today I will discuss why cloud and DevOps came into the market. Right? So my first question would be why we need cloud and what is cloud? Do you know? Let me introduce that. So if we need an application to be hosted on internet, or if that deployed on the internet, that means it's publicly available, right? So we need some servers. Now, what is a server? What is a server? A server is a specialized computer which is responsible to provide a service to another computer, which is also known by client. So, like if you uh, if you want to search in a Google, so for Google you are client, I am client. You are seeing this video on YouTube, so you are client of YouTube, and this video is hosted by a server. But these servers are managed by YouTube. But the server management is a very hectic task. Firstly, to set up a server, we need a land area to install data center. Now, in the data center, there are lots of servers. The electricity should be available for 24/7. So we need a backup power generator also. You need internet connectivity. If you don't have internet connectivity, then how should a server gives you the hosted application? So internet connectivity should be up all the time. That means 24/7. Now the server rooms are pretty hot, so it needs to be air cooled all the time. After all these, if there is a high demand of an application, the scalability is an issue. So it is difficult to scale up and scale down very quickly. On-prem infra can be a vulnerable to the data loss and in a event of disaster. Disaster can be anything like fire, flood, power outage, etc. And now to run those servers, we need some IT staff to manage and maintain those servers. Now, for these problems, cloud computing is an extremely helpful solution. We need, so we don't have to invest high upfront cost. For servers, you need to install land area. You have to buy a land area. You have to establish the data center. So it is a building like, so there is a high upfront cost, and there will be no maintenance headache also. So all the maintenance will be maintained by AWS or Azure or GCP. So we need so for scaling, we can scale the application without worrying a physical infrastructure. It is wow. So we can access the application all over the world, and most important, uh, the disaster in disaster situation, our data will be in a safe hand. So the all the important data will be managed by them. Them means cloud infrastructure, cloud provider. Okay, so let me go to the third slide. Now, as you can see the slide, so there are a lot of cloud providers which are available in the market. So we have AWS from Amazon, Azure from Microsoft, GCP from Google, and we have also, you can see that Alibaba Cloud, IBM Cloud, Oracle Cloud, who are providing the cloud native solutions. As per market share and popularity, AWS is leading cloud provider in the market. But Azure getting more attention nowadays, in my view. So, and I hope in 2 3 years, maybe Azure will be leading market with AWS. I mean, sharing market with AWS in a leading format. So now all these cloud companies provides more or less similar services. So the main service of a cloud provider is a virtual server. So what is server? I have also described that a server is like a computer. So it is a virtual computer. So AWS called it as a EC2, which is Elastic Compute Cloud. EC and Compute Cloud means two. So EC2. Azure called is a VM, which is virtual machine. Google Compute Engine from GCP. So the cloud providers are also provide cloud storage services, which include S3 from AWS, I mean blob storage from Azure, GCS from Google. Now you can see the GCS means Google Cloud Storage. Okay. Now, AWS provides RDS for database services, Elastic Beanstalk for application deployment without wiring the underlying infrastructure. I mean, for EC2, we have to maintain all the things, means the infrastructure, or not the infrastructure level, on the OS level and the application deployment level. You can the, so so sorry sorry for that. Okay, it's my mom. Okay. Uh, then, so AWS provides RDS for database services, Elastic Beanstalk for application deployment. So, what is Elastic Beanstalk, and why we need Elastic Beanstalk? That a different question. I will not go in the deep today, but I will do it surely. So, in EC2, you have to maintain the application, you have to maintain the codes, but in Elastic Beanstalk, you don't have to worry about the underlying infrastructure. So that is a win-win situation. And for Lambda function, it is for event-driven work and running the codes, basically running the codes, and for some task, it is important. Now, entire cloud service are divided into three main services. What are those? IaaS, which is infrastructure as a service. PaaS for platform as a service, and SaaS for software as a service. Now in IaaS, we only have to manage the operating system, middleware, and the application. So you can see that uh, okay, okay. So this is for my management, and this is for others management. So these are all managed by cloud providers, but these are for my management or and client management. For AWS, I am also client, right? Okay. Now, so IaaS only have to manage the operating system and middleware of the application. So while cloud provider will manage the underlying infrastructure like networking, storage, and virtualization like hypervisors. So basically, the EC2 is deployed upon hypervisors. Right? So the example of IaaS would be EC2 for AWS VM, Google Compute Engine. So those are IaaS. Now, in case of PaaS, which is PaaS service, um, some call PaaS, some call PaaS, oh, whatever is suitable for you, that will be good. Now, for PaaS, all the middleware, runtime, servers, networking, those all are managed by cloud providers. You can see that runtime, middleware, OS, virtualization, servers, storage, networking, all those are managed by cloud providers, right? And you only have to manage the application and data. So it's your application, you give to them, and they will deploy on the PaaS service. Isn't, I mean, isn't impossible like, right? But it is possible. Okay. So the past example would be Elastic Beanstalk, OpenShift. For it is OpenShift for Kubernetes deployment. I will discuss Kubernetes in a little bit, and Google App Engine for application deployment. So Elastic Beanstalk and Google App Engine is similar kind of thing. And in SaaS, now let's talk about SaaS. In SaaS, is everything is managed by cloud provider. So all the softwares are basically SaaS. Software means YouTube also SaaS, and you have to use them and get the services. Just that. So Gmail, Google Drive, Zoom, Meet, YouTube, all of them are example of SaaS. So now you understand the uh, importance of cloud providers and what is cloud. You understand. Now, DevOps. Now you have understood the advantages of cloud platforms. Let them move direction towards DevOps. Now, DevOps is a culture that developers and operation teams work together. It is like a bridge of developers and operation. Before diving deep into the DevOps, let's check why organization need DevOps mindset. In today's world, we need fast and reliable products, right? So just fast, 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 fast. So, but we don't have a smooth, error-free process to deploy and product release. So whenever there is a point of new releases of an application or any product release, so we experience a chaos. And why is this chaos happening? It is because arguments that whose fault it is. If there is a fault in application, whose fault it is? It is mine or yours. Like if I operation guy, so operation guy like be like it's your operation. I mean your fault. And development guy will like be like it's running on my system. Right. So that is a very chaotic situation. If you dig up the issue, so you will always see that we have communication issues. So there is a communication gap between development team and operation team. So we have collaboration problems, we have coordination problems, all those. So that's why DevOps came into the picture. By DevOps practice, we can automate SDLC, which is software development lifecycle. So that is a lifecycle of a software development. By DevOps practice, we can collaborate, communicate with each other more efficiently. We can have better management, which reduce the wastage. What is the waste? Which wastage? Time wastage. Because we have to deploy the application more faster away, right? So a developer can focus more on the user needs rather than going into feedback loop, right? So, okay, now let's try to deploy an application. So you have some code and you want to try it in a virtual server or virtual machine and make it available for the world. But there is a question: how can I manage my code? I have my code, it's okay, but how to manage it? We need a version control system. Hmm, what is version control system? Now, Git is a VCS tool, version control system tool, by which you can manage the code efficiently. It makes easy for multiple people work together in a simple same project. Now, and for an application deployment, you are not the one who is writing code. There are a team. There is a team who are making it possible to make the code run. Right. So there should be an efficient way to manage the code. Now you are working on a line and your friend is also running on same line. So that is not an good way to writing code. So you are writing on some line or some file. Your friend should be writing on another file and then merge it. Then make a total file, and that makes a good project. So Git make easy for multiple people to work on a same project, right? Git can maintain the history of the code. So it's a version history. So you can track the changes. Now, Git is flexible for small code base, also larger code base. So it is flexibility. Git is flexible. By using Git, providers be like GitHub, GitLab, Bitbucket, we can share our code to others, and also you can make the code private. You can have password locked code. So only authorized users can only use the code. It can be possible. Now that we have managed my code, I want to deploy the application on multiple servers. But if I want to provision multiple servers, that is a hectic way to create servers. If you want 10, 20 servers, virtual servers, it is manually by manual, it is okay. But if you want 100 servers, how can that is possible? um, to provision 100 servers, it is a very huge problem, because if you want to create a server like go to console, AWS console, and go to launch instance and fill up all those things, fill up those things and create one server. Now AWS has a feature that you can create multiple server in one time, but it is not the correct way to create the same, right? So we need Terraform. What is Terraform? It is an infrastructure as a code tool. By Terraform, you can provision, create an infrastructure by using some lines of code. You can create infrastructure, sorry, you can create infrastructure in multiple cloud platforms like AWS, GCP, and also in GitHub. You can create a repo, delete a repo, or any other things you want to do. In GitHub is also it's possible. So by using Terraform, you can automate the process of creating an infrastructure. Now, in Terraform, there are standardized code available in Terraform site by which you can easily copy paste the code and make some changes and create an infra in like minutes, right? You want to create hundreds of infra at once, you can do that. You want to destroy those infra at once, you can do that. So Terraform has a state management system which keep the track of changes of the environment. So if you want to look back to the previous state, or track the version, so it is possible for in Terraform. Now, Terraform destroy command is also a convenient way to destroy all the infrastructure at one go. So Terraform is a powerful tool, and it is very popular tool according to, in occurrence of infrastructure as a code tool. Now, now that you deploy all the servers, and I have all the servers in front of me, like in AWS or Azure or GCP or Oracle Cloud, right? IBM Cloud, wherever, right? So now, if you want to deploy your application on a faster way, how could you do that? I mean, you can SSH to your instance and then update your instance and then install the application and let them aside, and you go to the second application, second server, and install the application, update the application, update the server. So this is a hectic way to go do that. So how do I do those changes? Now, creating infrastructure is another way. But if you want to install your application on those 100 servers, so that is a very hectic way. And for that, you need configuration management tool. Now, configuration management tools which are responsible to configure your servers at once, or by using some codes you can configure those servers at once. So there are some tools are available which are very important, and those are very popular. One of them is Ansible, one of them is Safe, and one of them is Puppet. Now, configure management tools are required to maintain and update and install the application on those hundreds of servers in one go. But you need a master machine. You just need a master machine, and you need those servers IP addresses. You can have the IP addresses from anywhere. You're locally in AWS, you're locally you have all those IP addresses, and you just go and install those IP addresses. I mean, copy those IP addresses into a master machine, and just in one go you can update those hundreds of machines in a second. It is actually fast creates a faster deployment process and create a disaster recovery. I mean, after a disaster, you can recover your application in a faster way. Obviously, you can do that. Now, if you want to deploy your application in minimal storage, in a server, you are uploading, I mean, updating the server and installing the application. So it is a server, right? So in a server, one application is there. So you want to minimalize the application size. How to do that? Because if you want to deploy an application in single VM, it will cost your pocket. In a single application, you pick one server for same application. Now you want to scale, right? You want to scale the application, right? So you need lot of servers. So that will cost your pocket. That is where containerization techniques came in. Now, Docker is a executable, standalone, lightweight package of software which have everything for running an application. Docker is a containerization technique, and it is lightweight and is a software package which have everything to run an application. It uses a kernel of host operating system. I mean, if you install Linux operating system, it uses the Linux kernel to deploy the application, right? So Docker uses minimal libraries, minimal binaries, which is only responsible to run that application. It does not take extra binaries and libraries. So that makes Docker a lightweight. Now, Docker containers encapsulate the application in their dependencies only, which makes it portable in external environment. So if you have an application which is Dockerized, now a developer guy Dockerized the application and it gives to uh, and he gives to operation guy that Dockerized application. So he just need to open Docker. He just need to start the Docker. That's it. So it is a portable way to uh, instantiate the application. No matter where you are working, Docker containers will work same way. It offers high level of isolation, which ensures security perspective also. Now let's you you look like confused in this. Like one Docker is there. In one Docker, one application is there. Now you want to scale the application. How can you do that? So you need multiple containers. Easy. Okay. You have multiple containers. and you need now that you have to manage those multiple containers. Now, container management is a big issue. Docker is there, but Docker cannot manage those multiple containers. Now, not only multiple containers, if that multiple containers is used, opened in same server, that is okay. But in multiple servers, multiple containers are there. In multiple servers, multiple containers. I mean, in two servers, there are five containers, five containers in multiple servers. I mean two servers. So the management and connection, establish the connection, is very important, and it's a very hectic way. Very headache. It is a very headache way. So, but you cannot scale the Docker container. It is an very um, so you cannot scale the Docker container, and to manage the multiple Docker container you need Docker orchestration tool. Now Kubernetes is a way to orchestrate those containers. You can create multiple instances of a container and distribute those workload efficiently using container orchestration tool such as Kubernetes. There is OpenShift. So that is also a Kubernetes, but it is managed by OpenShift. So Kubernetes can manage your workload and scale the application efficiently. You can also load balance the application if any container goes down. Let's say in container goes down and Kubernetes detects it. Kubernetes can detect it and create the container in less time. That means if a container is like there is a problem in a container and the container goes down. Now Kubernetes have those intelligent brain that it can detect that, oh, one container is down. Let's create another container to match up the application count. So you can manage role-based access controls also, which role-based access control which calls at RBAC with Kubernetes. So if you want to access only few people, you can do that. So it gives you a separate and portable environment to deploy your application. But you deploy those applications, it is a good. So we have deployed our application at last. But there is a catch, which is I want to automate the whole thing from infrastructure to deployment. How can I automate all those things at once? Now, to automate all those things, mm, so automate all those things, we need a automating tool, right? So, is there any way to automate the whole thing? Yes, there is a way. Obviously, there is a way, which is continuous integration, continuous deployment, which calls as a CICD. The short term is CICD. So CICD, that is where CICD came into the picture to automate the whole thing. The CICD means continuous integration and continuous deployment or delivery. Now there is a difference between continuous deployment and continuous delivery. That is another topic. Let's leave that. Now you can Google that also. So you can understand what is the meaning or what is the, there is a very minimal meaning, but let's leave that. So now what is continuous integration means? In CI/CD, CI means continuous integration. That means that developers frequently merge the code into the central repository like Bitbucket, and any other GitHub or any other central repository. From there, the deployment kicks in. The CI also involves using automated tools, which is used to check the code and verify the correctness of the code. After successful verification of the code integrated, uh, sorry, after successful verification, the code can be integrated to the repository. Now we understand the continuous integration part. So there is a one another thing, continuous delivery part or deployment part. What is that? Uh, in this approach of continuous integration and continuous delivery, in CD approach, we deploy the application to the servers. CI is the to take the code from uh, mm, take the code from developers, and CD is the deploy the code to the servers. Now, before deploying the code into the servers, we have to test the code. We have to build the code and make sure the code is correctly built, and we have to run the code and test the code. Sorry for that. We have to build the code and test the code that the code is running successfully, right? Now the then we can deploy the build to the servers. I mean, by running the code, build the code, test the code. After that, we can deploy the builds to the servers. Now, one of the main focus in continuous delivery is to build, test, and release the code as quickly as possible. That is where DevOps came into the picture, right? In CI/CD, we can automate the whole thing and directly deploy the code as quickly as possible. Now, Jenkins is a CI/CD tool by which we can perform all those things, and all those things like to integrate the code to deploy the code. Okay. Now Jenkins is a CI/CD tool which have with all the tools integrated. Okay, which I have discussed earlier in this section. So Jenkins is open source, which is written in Java language. So you have to install Java in the server to run the Jenkins. Now Jenkins is a free of cost because it is open source. By Jenkins, you can control multiple nodes. Now nodes, what is nodes? Nodes means server. You can manage those servers, and but only Jenkins cannot perform all the tasks. Mark my word. Only Jenkins cannot perform all the tasks. But Jenkins is doing all those things. How? Because Jenkins have plugins. Plugins makes Jenkins stronger. There are a lot of plugins in Jenkins. So we can integrate those plugins and deploy the server, right? So there are many open source contribution. Sorry. There are many open source contributions to the Jenkins plugins, which makes Jenkins actually powerful for a CI/CD purpose. Now, in summary, I would say like cloud computing and DevOps have transformed how we build, manage, and deploy the application. Now, cloud platforms like AWS, Azure, GCP makes easy to organize the organizations, easy to organize the servers, and it makes easy for organizations to access the server, not only server, storage, databases without needing a physical server or physical infrastructure. This makes easy to scale, reduce the cost, and improve data security, availability, and fault tolerance. Now, DevOps brings deployment and development and operation teams together to work more efficiently and deliver the products in a faster way. Uh, Using tools like Git, Terraform, Ansible, Docker, Kubernetes, Jenkins. Also, there are more tools like Prometheus and Grafana. All those are for monitoring tools. For monitoring purpose, all those are used. I have not included that in this slide, but for monitoring and logging, for logging, actually basically used Prometheus, and for visualization those logs and monitoring purpose, Grafana is used, right? So these tools makes easier to automated the repetitive task, right? To check the application, to secure the application. So there is any vulnerabilities are there or not. So for vulnerabilities, there are one tool like SonarQube that is also used. I have not included that, but I have gone through some basic only some basics way, and which helps to contribute better and speeds up the deployment process. Together, cloud and DevOps make this easier to launch, manage, update the application, allowing business to be more agile. Agile is a software development lifecycle way, and it is a reliable way to deploy the application or manage the application, and not going through a feedback loop. And it is and the application should be ready to meet the user needs and needs more quickly, right? So that's it for today. My name is Soumik Mondal, signing off.